Alright guys, so what we're trying to figure out in this case is, let's look at the quick version of the quiz, right? So what we want to know is exactly which types of innovation should we choose, or what ought to be our innovation choice mix, so that we will know exactly how much to allocate so that we can meet some of the guidelines and constraints. So in this case, you've got innovations, you've got A, B, C, D, and E. 5 different types of innovation patterns that you hold. What you want to know is, what would be the right innovation mix, right? So assume everything. So it doesn't matter if it's $1 million invested, or 20 million, or 50 million. It's basically you can convert everything to a percentage. So let's start by saying that everything is going to be 20%, right? So let's keep everything as 20%, right? If you want to make it look like a percentage and you'd be happier with it, fair enough, just go into format cells and choose percentage and let's keep it at 1 decimal place, and there, voila, you've got it. And same thing out here too, have everything in percentage, and we'll keep it at 2 decimal places, and we've got it, right? Same here, we keep everything in percentages, and where is percentage? There, we've got it there. Same here, format cells, percentage, and there you go. So, once again, you've got 5 different types of innovations here. Assume you're balancing everything out, which means you're allocating exactly the same percentage to every innovation, right? Next, you're plotting out feasibility. So if it's feasible, it's 1. If it's relatively less feasible, it's a 0. So based on the question itself, it says feasibility for innovation A is it's less feasible, B is more feasible, C is not very feasible, D is not very feasible, E is feasible, right? Now, this calculation is simply put nothing but the sum product, which is this times feasibility, innovation A's percentage times its feasibility, plus B's percentage times its feasibility, plus C's percentage times its feasibility, times D's percentage times its feasibility, and times E's percentage and its feasibility. So instead of calculating it as B2 times C2 plus B3 times C3 plus B4 times C4 plus B5 times C5 plus B6 times C6, what we instead do is we use something called a sum product, which basically just calculates the entire array, right? So sum product of this whole set and this whole set, right? And we should get exactly the same bit out here, right? So we should get exactly the same piece out here. Now, the same bit with risk. We know innovation A is riskier, B is less risky, C is less risky, D is riskier, E is riskier. Tax sheltered, innovation A has specific tax shelter. Maybe it's in biotech. These are typically tax-sheltered setups. B is a tax-sheltered innovation. C is not a tax-sheltered innovation. D is not a tax-sheltered innovation. D is a tax-sheltered innovation, and E isn't one. And then finally, you've got returns. A provides you a 9.5% of return on every dollar invested. B 8%, C 9%, D 9%. And E 9%. So based on that, you can calculate how much of your innovation portfolio mix you have, and you can calculate that. So just the roundabout way, a more longer way of calculation is total return would be calculated as this times this plus this times this plus this times this plus this times this plus this times this, right? Which is exactly the same as what we find here. So instead we just used a sum product. Now comes the story of the constraints. So what you're trying to do is, well, prior to going to constraints, very important to understand is what you are trying to do now is you're trying to increase the total returns in this cell. So you're trying to increase the 8.9% to maximum possible returns, right? Now, of course, the whole set out here is, here are some of the constraints. Firstly, your portfolio has to balance out. Therefore, all the percentages together should be less than or equal to, should be equal to, not less than or equal to, but equal to 100%, right? Feasibility. They've said that the company wants to invest at least 50% of the money in more feasible issues, right? So you want 50% or more of your money to go into more feasible type of innovations, right? Right now it's 40%. Next, your risk. You want the number of, or the percentage of your risky innovations to be less than 50% of your entire innovation portfolio. And you want your tax-sheltered innovation to be at least 30% of your innovation portfolio. So it should be greater than 30%. So feasibility of your portfolio ought to be greater than or equal to 50%. Risk should be less than or equal to 50%. Tax shelter should be greater than or equal to 30%. The last guideline, which is at least 40% of the total return, should be tax sheltered. Now, which ones are tax sheltered? Innovation A, Innovation B, and Innovation D, right? So what's the return from just these three innovations? So all we do therefore is equal to this one times, whether it's tax sheltered, right, times this plus this times this times this plus this times this times this, right? These are the only tax sheltered ones, right? Click OK. So it tells you it's 0.053, which is exactly the same as 5.3%. All it's saying is that at least 40% of the total return, right, of the total return should be tax sheltered. Now, what's the 40% of the total return is? The total return is out here. So you're saying that is equal to 0.4 times, right, which is 40%, times your total return, right? And you've got it right out there. So all it's saying is this percentage should be greater than or equal to this. That's your final constraint. Now after this, you should be able to run it in Solver and tackle the rest, right? All the best. Thank you very much.